In this video, we're going to be looking at some x and y intercepts. So the reason we want to find these x and y intercepts is because it's another way to graph these equations or to analyze the graphs of these equations, which we'll get to. So in our last video, we looked at graphing lines and linear equations. The only way we've done that so far is by converting everything into slope-intercept form and then graphing that. Well, finding these intercepts can be another way to do that, to graph these standard form equations. Okay, so the first thing we want to look at is what are the intercepts? So the x-intercept is wherever the line crosses the x-axis. So it would be right there. So that's my x-intercept, right? Kind of self-explanatory and kind of common sense for these ones. So then that would say that my y-intercept is where I cross my y-axis. Okay, so we can look at our graph to find those points. So for example, over here in this graph, the x-intercept would be at 1, 2, 3, 4, 5, 6, 7, 8, would be at 8, 0. And my y-intercept, let me get the right color, and I'm just using colors here just because I like to separate things by colors, would be 0, and then 1, 2, 3, 4, 5, 6, 7, 8 as well. Okay, so that's one way we can find those points is by using the graph. Well, what if we don't have a graph? So if I don't have a graph, to find the x-intercept, one thing you'll notice is that the y value is 0, right? Because when I'm on that x-axis, my y values, I have not gone up or down at all. I'm still right there. So my y value is 0. So I set y equal to 0 and solve for x. Okay, so then again, to find my y-intercept, I see that my x value up here is 0 because I haven't gone left or right. So that's the same kind of thing. So I would set x equal to 0 and solve for y. So let's look at this example. So I want to find the x and y intercepts for this equation. So to find my x-intercept, I set y equal to 0. So I've got 0 equals 3x plus 6, and then I solve for that x. So I subtract my 6 and divide by 3. So my x-intercept would be at -2. So I want to write this as a coordinate point and not just leave it like this. So I know I've got -2, 0. So that's how I'm going to finally write my x-intercept. This x equals -2 is not a point on a graph. It's just it's actually a different line that we can look at later. So we want to actually write it as a point. So now let's find the y-intercept. So to find the y-intercept, I set my x equal to 0 and I solve for y. So I've got y equals 3 times 0 plus 6. So y equals anything times 0 is 0 is 6. So again, I want to write this as a coordinate point. So I've got 0, 6. So that's the y-intercept of that equation. Okay, let's look at one more. Let's look at example number 2, and then you have time to work through some of these other ones on your own, and I'll post the answers. So let's find the x-intercept first. So to find my x-intercept, I set y equal to 0, and I solve for x. So the first step, I would add 8. So I've got 8 equals 1/2 x. So I did this one on purpose because we tend to freak out when we see fractions, and it's really not that big of a deal. So I notice, and I know that dealing with fractions, this 1/2 times x can also be written, and I'm going to write it up here, can be 1x over 2 equals 8. Well, if I have something written like this, I can get rid of and deal with the denominator first, and in order to do that, I multiply by 2. So I would get rid of the denominator, right? I'm undoing that division, so I'd have 16 equals 1x. If I had a different value than a 1 in that numerator, I could then divide both sides by that. So my x-intercept, right, would be 16, 0, because I always want to write it as that coordinate point. So now let's find the y-intercept. And to do that, I set my x equal to 0. So I've got 1/2 times 0 minus 8. So anything times 0 is 0, so y equals -8. So again, I want to write that as my coordinate point, so 0, -8. So there's my two intercepts. Okay, so now I want you to go and try these other couple of examples and see what you get when you're working through that. So the cool thing now is we can use these intercepts to help us graph. So we don't have to convert each thing, or each equation, to slope-intercept form first. and then graph it. We can use those intercepts to help us graph. So I want to walk through just a couple of these examples with you, and then you will work on your own for a few minutes to try and figure this out. Okay, I'm going to leave example 7 because it's a little more simple, and I think you can handle that one. So let's look at example 8. So the first thing I'm going to do is I'm going to find my x-intercept. And to find my x-intercept, I turn my y value to 0. The cool thing about doing this is when we're in standard form, that means that this chunk will just go away. So now I have negative 4x equals 20, and I divide by negative 4, and so my x-intercept is going to be at negative 5, right? And remember, we write this as a coordinate point, so I've got negative 5 comma 0. Well, let's look now, and I'm going to erase that, for my y-intercept. So the other cool thing, when my y-intercept, I turn my x 0, which means this whole piece goes away. So now I've got 5y equals 20, and I divide by 5, so y equals 4. Again, I write it as a coordinate point, 0, comma 4. So now that I have those two values, I can graph them. So 1, 2, 3, 4, there's my y-intercept. And my x-intercept, 1, 2, 3, 4, 5, would be there. So now that I have 2 points, I can connect any 2 points by a straight line, and I would have my line, again using a ruler. There we go. So I want to go ahead and now I can use this instead of trying to convert this equation back to slope-intercept. If you're more comfortable doing that, great, do that, because you'll get the same line and the same answer. It just may take a few more steps, but now you have another way to go about this. So there's a couple more examples that I want you to try. Double check that you're doing it right because I'm posting the answers for you, and then go ahead and jump into that homework that you're working on for this section.